The previous lesson we looked at one-step inequalities, but we only used addition or subtraction to solve the inequalities. This time we're going to be using multiplication and division. And so right here, I'd like to draw a parallel between what we know with the equations and to what we're going to be doing with the inequalities. 2 is timesing the x, and it equals 8 here in this equation, so we would divide both sides by 2, and that lets us know that x is actually equal to 4. Well, this inequality right here is very similar to the equation, it's just that the signs are different, but we're going to actually solve it the same way. 2 is timesing the x, so we will divide it by 2, and then we can divide the 8 by 2 as well, and that leaves x being greater than 4. And I want to take just a moment to set this up so that way in the last part of the lesson when we look at a special rule you'll understand why we do this. So this is very important that you understand why we're handling it this way. If this is 0 and this is 4 right here, we know that we would put an open dot right here and we're saying x is greater than 4. So anything that's bigger than 4 would actually solve this inequality. And so what that's literally saying is that 5 would be a solution. And so if I substitute the 5 in for the x, we have 5 being greater than 4, and that makes complete sense to us. So the shaded region should represent all the solutions to the inequality. And because we left it as an open dot, we're saying that 4 would not be an answer to this. 4 is not greater than 4. So hopefully that part makes sense, and then that lays some good groundwork for when we cover a special situation that we'll get to in just a bit. Before we go to that special situation, though, I want to have a take a look at this situation where division is happening. T is divided by 2 in this equation, so we would multiply it by 2. And then to keep the balance of the equation, we would multiply the other side by 2, and so T would be equal to 20. And here with this inequality, this less than or equal to sign, we would handle it the same way. T is divided by 2, so we would multiply by 2, and that frees the t up right there. But then we need to multiply the other side by positive 2. And so t would be less than or equal to 20. And we're going to take a look at the graph on this one as well. We'll go ahead and graph our solution. If this was 0 right here, and this was positive 20, I would have to put in a solid dot here on the 20 because we're saying 20 could make the statement true. 20 is less than or equal to 20. It's the equal to part that makes it true. It looks weird, but it is a truthful statement. But what's less than 20? Well, it's everything to the left of 20. So I'm getting my highlighter out here to shade this instead. Makes it a little bit easier. And we would say any point in the shaded region would make this inequality true. So let's just pick a random point. Let's just choose negative 20. Well, last I checked, negative 20 is indeed less than positive 20. But because we have this closed dot right here, we're saying 20 could also be one of the solution points. So again, if it's closed dot or in the shaded region, it's part of the solution. Up here, the shaded region is the solution, but since it's an open dot, we're saying 4 would not be part of the solution there. So we've handled the basics of this topic, one-step inequalities using either division or multiplication to solve. What we're going to look at now is a situation that causes issues, and if people don't understand why we do this certain rule that I'll teach you in a bit, it messes up everything that you know. So here, let's look at two different inequalities, and this will flesh out the problem that we're going to be faced with. Negative 2 is timesing the x, so we would divide by negative 2 on both sides. So from what we know, x would be greater than negative 6. Okay? Over here, it's positive 2 times x, so we would divide by positive 2 and divide by positive 2. And x would be greater than 6. So everything looks like it's going okay, and that's fine. There's no reason to make this more difficult than what it needs to be. But let's go graph it, and let's see if our shaded region actually shows us the solution to each inequality. So here's 0. that's negative 6, so I need a negative 6 on here. It's going to be an open dot because it's greater than. And we're going to shade all the numbers that are bigger than negative 6. So this entire shaded region is my solution. Let's go ahead and graph this other one real quick before we start checking. Here's 0. Here's positive 6. And let's go ahead and graph right up there. And again, I need a open dot right at 6. Now, let's see where the problem is, because right now I don't see, most of you that are not familiar with this are probably not seeing an issue. If you're familiar with this, you probably already know where we're going, but I could choose any point from this and it should make it true. So if I chose, let's just use positive 6. Positive 6 times negative 2 would make it negative 12. Does negative 12, is it actually bigger than positive 12? No, maybe there's just something wrong there. Let's use 0. 0 times negative 2 would be 0. Is 0 bigger than 12? What if we used negative 3? You know, because that's in the shaded region. If we've done this correctly, our shaded region should show us the solution. Negative 3 times negative 2 is positive 6, but positive 6 is not greater than 12. So we have a huge issue here, okay? We've got an issue here on this left side. Let's go see if we've got the right side issue. Let's just choose 7 because it's just real close. 7 times 2 is 14, so is 14 greater than 12? Yeah. So this one's okay. We've handled it the right way. So let's look at seeing what's different. This is a negative 2, and it's multiplying the x. This is a positive 2, and it's multiplying the x. And they're both greater than 12. So the only difference, I mean the only thing that's different, is that this is a negative 2, and this is a positive 2. So when I went to solve this, I divided by negative 2, and divided by negative 2 on this side. And over here we were dividing by positive 2's. That's the only difference. That should tell us that there's something up when we actually go and divide by a negative number. And that means that if I divide by a negative number to solve these inequalities, I've got to do something to fix it. Basically, everything that's on the shaded side is all wrong. If I was to choose this other side, like negative 7, what's negative 7 times negative 2? Well, that'd be positive 14, and positive 14 is bigger than 12. So if I could just go through and choose this other side, I'd be fine. Well, that tells us what we can do. Whenever you divide or multiply by a negative number, we need you to turn this inequality sign completely around. So x is less than negative 6. And then that lets us be able to shade everything in there, and that gets the negative 7, which made it true. Negative 8 times negative 2 would make it 16. Everything that's to the left of it would actually make this true. And all that we had to do was turn the inequality sign around. But we don't want to do that over here because that would make it all false. We don't want to say 5 is an answer because 5 times 2 is 10, and 10 is less than 12, not greater than. So we only want to turn this inequality sign around when we're dividing by a negative number or if we're multiplying by a negative number. So let's look down and look at that other situation right here. And hopefully this will help kind of take a little bit of the confusion out, and we will explain exactly what's happening with each one. This is a positive 5 times the y, so I need to divide by positive 5. Now this is a negative 25, but I'm going to divide it by a positive 5. And my rule is pretty simple. When I'm dividing by a negative number, I turn this sign around. I'm dividing by a positive number here, so I do not turn this sign around. Y is going to be less than or equal to negative 5. So here's 0, and here's negative 5. It needs to be a solid dot because negative 5 could be the answer, and I'm just going to shade to the left. If I put in -6, for example, that's in the shaded region, -6 times 5 is -30, and -30 is less than -25. So we made the right call. We did not flip that. Why? Because I'm dividing by a positive number. Now, let's come over and let's do this one right here. M is divided by a -2, so I would multiply by a -2. And so I multiplied this side by -2. And it's because I'm multiplying or dividing by a negative number that I take the inequality sign and I just flip it around. And that means that anything greater than 16 will make this true. 16 can also make it true. I put a solid dot here and I shade it in. And let's just check this one right here. Let's just see if it makes sense. If I chose -20, or excuse me, if I chose +20, 20 divided by -2 would be -10. And -10 and -10 is actually not bigger than -8. So we've got a slight issue there. And let me just erase this and let's try this over. Sometimes it happens and you just start over again. So let's just take everything off and let's just start over from scratch again. Again, there's nothing to be flustered about. You just start over. If m is being divided by -2, we'd multiply by -2 on both sides. So m would be less than +16. There's my issue right there. Here's 0. Here's +16. It would be a solid dot to include that 16 is part of the solution, but less than I would actually be shading to the left because that's less than. So 20 would absolutely not work, but to the left it does. So let's just choose like +8. That should be a solution point. 8 divided by -2 is -4. And -4 is indeed bigger than -8. And if I went on further, let's just choose let's use -10. -10 divided by -2 is +5, and that indeed is very easy to see that 5 is greater than -8. So it works when we're dividing or multiplying by a negative number. Turn the sign around. When we're dividing or multiplying by a positive number, see those 5s right here, the red, we don't turn it around.